Now introducing the intercept form version of a quadratic function for the first time. Really all that intercept form is for a quadratic function is just a factored form of it. So it's just going to be a couple of binomials that start with x and x. And you'll just subtract some number p and then subtract some number q, whatever those numbers might be. And then you can also have some sort of a constant up front. So I'll just write in a. So it turns out that that a value has the same sort of effect that it does when you're dealing with vertex form or standard form of a quadratic function. So like if a is positive, the parabola is going to open up. If a is negative, the parabola is going to open down. If a is like a 2, something that's bigger than 1, it'll vertically stretch the graph. And then if a is like 3/4 or something that's less than 1, it'll vertically compress the graph. So it'll have all those same effects. All right, so let's take a look at graphing a parabola that's in intercept form. So you can see that what we're going to graph right here is this function h of x equals 0.25 times x minus 1 times x minus 9, right? All right, so the biggest thing that is easiest to find when it's in a factored form is actually the x-intercepts. So we're going to start with that. And the reason why it is the easiest is because if an x-intercept has a number for its x-coordinate and then always a 0 for y, then we can plug in a 0 for y. And so if I do so in this particular equation, it actually becomes really easy to find the x-intercepts because it's in a factored form. So if we use the zero product property, either x minus 1 or x minus 9 has to equal 0. So that means x equals 1 or x equals 9. So we get 1, 0 and 9, 0. Therefore, have to be the location of the x-intercepts. So then on the graph, I can go dot, and that's going to be where those x-intercepts are. So then actually, if we want to now graph the parabola, since the parabola is symmetric, then the middle of the parabola is actually going to be in the middle of these two x-intercepts. So if I want to find like the axis of symmetry, right, what's going to cut this parabola in half, I just need to find the middle of 1 and 9 because those are the x-intercepts. So the axis of symmetry is going to be the middle of 1 and 9, and if you want to find the middle of two numbers, you just got to find their average. So to find an average, you add the numbers together, divide by how many there are, right? So it's going to equal 10 over 2, which equals 5. So x equals 5 is actually just the location of the axis of symmetry. And yeah, okay, that's right in the middle, right? So that makes sense. Beautiful. So somewhere on that line has to be where the vertex or the tip of the parabola is. So the vertex has to have a 5 for its x. And then you can find the y if you just plug the 5 into the equation. So if we do h of 5, it's going to be 0.25 times plug in 5 for x minus 1 and plug in 5 for x minus 9. So if we simplify that, it's going to be 0.25, 5 minus 1 is 4, and 5 minus 9 is negative 4. And then if we do 0.25 times 4, that's 1, and then times negative 4, which equals negative 4. So there we have it. 5 and negative 4 gives you the location of the vertex. So I can put a dot on the graph right there at 5, negative 4. And then if I want to get a nice, accurate sketch of this graph right here, I can recognize the fact that this a value is 0.25. So what that does mean is then 1, 4, 3 squared, 4 squared, 5 squared, 6 squared, right? Instead of going up by that much each time, it's just going to go up a quarter of it each time. So a quarter of 1 is 0.25. If I multiply 4 by that 0.25, you get 1. And then you get 2.25. This would be 4, 6.25, 9. That's just multiplying everything by 0.25. So what that really just means for us then is you're just going to go up 0.25 when you go over 1 instead, and then you'll go up 1 when you go over 2. You'll go up 2.25 when you go over 3. You're going to go up 4 when you go over 4. You're going to go up 6.25 when you go over 5, and then you'll go up like 9 when you go over 6. So something like that would give you a really good, accurate, nice sketch of that particular parabola there overall. And then finally, the last characteristic that we'd want to find here, I guess, is find the y-intercept. And we know that a y-intercept has a 0 always for its x-coordinate. And so you could find it from the equation if you plug 0 into the equation. So you could do 0.25 and then 0 minus 1 and 0 minus 9. That's equal to y. So that's just going to equal 0.25. 0 minus 1 is negative 1 and 0 minus 9 is negative 9. If I multiply those two together, you're going to get negative 0.25, and then you times it with negative 9, and that's going to give you positive 2.25 equals y. So therefore, the y-intercept should be occurring at 0, 2.25, and you can check and verify on your graph that that is indeed where the y-intercept is going to occur. Okay. All right, so that's our nice, good first example that we want to work with right there. So kind of some special things that will happen with some of these other examples right here. So you can see that instantly, like this is in a factored form. So instantly you should be like, okay, I know where the x-intercepts are going to occur, right? So if you have this factor of x plus 3 and x minus 2, then that means at negative 3, 0 and positive 2, 0, that's where those x-intercepts are going to occur. So I'm going to go ahead and plot that at negative 3 and at positive 2 for these x-intercepts. So we know this is going to be a parabola, so that means the middle of the parabola is going to have to be right between negative 3 and 2. So I can find the axis of symmetry if I average those together. So negative 3 and positive 2 added together, and then divide by how many there are, which is 2. This is going to give you negative 1/2. So we kind of get like a decimal sort of middle part of the parabola, because that means like this right here, right between 0 and negative 1, is going to be the middle of your parabola. So you're going to have to then, I guess, plug in negative 1/2 for x to find the y-coordinate for the vertex. So that's going to kind of look like this then, I guess. We're going to have y equals negative of negative 1/2 plus, and then I'm going to write 6/2 because that's the same thing as 3, and then negative 1/2 minus 4/2 because that's the same thing as negative 2. The reason being because I need the common denominators, right? So we're going to get negative of 5/2 times negative 5/2. So then if you multiply that all out, it's a negative times a positive times a negative, which will give you a positive answer. And then 5 times 5 is 25, and 2 times 2 is 4. So 25/4 will give you the resulting y-coordinate. As a decimal, it is like 6.25 if you did 25/4. So you're basically going to have it be right there, right? So that's like negative 1/2 and 6.25, okay? All right, if you want to sketch out the rest of your parabola, you'll notice that it's a negative 1, so it's just going to be an upside down parabola. But really what will happen is just going to go down 1 when you go over 1, and then it'll go down 4 when you go over 2, and then if you go down 9, when you go over 3, it'll kind of look like that. So if you like, sketch it out, it'll like, yes, it'll hit the negative 3 right there, and then it'll hit the 2 right there as you sketch that all out. And then if you want to find the y-intercept, you just got to plug in a 0 for x into the equation. So negative of 0 plus 3 and 0 minus 2 is equal to y. So it's going to be equal to negative of 3 times negative 2. That's going to equal 6 right there. And if we check that all out, that seems pretty logical that it should be hitting at 6 right there. So excellent. All right, so this guy right here is also kind of unique and special because it is factored. You can see that actually you have like basically like an x minus 0 times an x plus 4, and then just with like a 3 in front as your a value if you want to think about it like that. So that does mean then you have x-intercepts at 0, 0, as well as at negative 4, 0. So right there and then right there. So it should be pretty easy to tell that negative 2 is right halfway in between. So negative 2 is going to be your axis of symmetry, which means, of course, your vertex is going to have a negative 2 for its x. And then you can just plug in negative 2 for x. So 3 times negative 2 times negative 2 plus 4 will equal the y. It's going to equal negative 6, and negative 2 plus 4 is 2. That equals negative 12 for the location of the vertex. So I can then plot negative 2, negative 12. It's going to have to be kind of somewhere down there where I made that red dot right there. You can see that because there's that 3, this is stretched by a factor of 3. So rather than 1, 4, 9, 16, you're going to go up 3, up 12, up 27, up 48, just 3 times as much. So you're actually going to go up 3 when you go over 1, and you go up 12 when you go over 2, that sort of thing to vertically stretch that parabola. And then the last thing that we'll want to find here is find the y-intercept, which has a 0 for its x. And then if you plugged in 0 for x into this one, you'd have 3 times 0 plus 4, which would be 3 times 0 times 4. And if you're timesing with a 0, it's just going to equal 0. So you do get a y-intercept of 0, 0, which lines up with exactly where that y-intercept is for that particular graph. All right, and then just one last one. This is kind of a special case because when it's in its factored form, you have x plus 5 as a factor as well as x plus 5 as a factor, which then means if you plugged in a 0 for the y and then you solve for x, you get -5 and -5 as answers. So when you get a 0, you get a -5 for x, and then also, right? So it's just going to have like one x-intercept. So that's going to be the only place it hits the x-axis at, which actually means that's where the tip of the parabola will be. Like that just touches the x-axis right there. So it's actually going to be the vertex, like -5, 0, and then also the axis of symmetry is -5. So then it's just a matter of like sketching out the parabola from there. Because this is a -2 right there, it's going to open downward and then also be stretched by a factor of 2. So rather than 1, 4, 9, 16, 25, 36, it's going to go down 2, go down 8, go down 18, go down 32, etc. So it'll go down 2 if you go over 1, it'll go down 8 if you go over 2. So it'll look something like that. And then finally, if we want to get the y-intercept, we can see that it's going to be somewhat of a negative number, right? So you'll want to plug in the 0 for x to find that y-intercept. So you have to do -2, 0 plus 5 times 0 plus 5 is going to equal y. So it's going to equal -2 times 5 times 5, which equals -10 times 5, which equals -50. All right, so 0, -50 is going to give you the y-intercept for that parabola.